I'm going to show one or two slides to make a couple of observations, and then I'm going to dive into technical demonstration. I'm going to show you more things than you'll probably absorb in the next 25 minutes. But what I want you to take away is that we are focusing on making the management of the open hybrid cloud very simple and very consumable. There's lots of reasons that we see customers deploying many clusters, either multiple clusters for development. I have individual single clusters with a team, but then I have many teams to support. Or I'm beginning to spread QA, dev, test, prod across clusters with a DevOps story. Or I have a large organization and I have a distributed multi-cloud. I'm running across different cloud vendors, or hybrid cloud. I'm extending from a data center out to a public cloud, and I have lots and lots of clusters. So we see these challenges with how do I make it easy then to make these clusters consumable, manage them consistently, et cetera. One of the offerings that Red Hat made available this year was advanced cluster management for Kubernetes. We're going to focus on 4 key areas. How do I lifecycle clusters that are under management? I'll talk about how it ties into what you just saw previously. How do I manage the configuration of these clusters consistently? How do I audit them? How do I enforce that configuration consistency? How do I deliver applications across these clusters? And if I have clusters running in different public clouds, how do I then make that a seamless sort of fabric that my application can leverage? And then finally, observability. If I'm running an application on multiple OpenShift clusters, how do I get a consistent view of whether it's healthy or not? So those 4 areas are going to tie into what you're about to see. Feel free to interrupt me as we go along. I'd love for this to be as interactive as possible. What you're looking at now is a dashboard that shows me multiple clusters, each of which you can see the version, so different versions of OpenShift. And what I want to draw your attention to is that, first off, some of these clusters, one of the ARO clusters and the ROSA cluster, these are actually the ones that you just saw from a SaaS perspective, where they're being provisioned and managed with an SRE team behind them, but I've imported them to be managed by Rackham. So Rackham is not a SaaS or an SRE managed thing. It's a piece of software. It's installed through an operator. It takes less than 10 minutes to install a Rackham hub into an OpenShift cluster through the Red Hat operator catalog. And now that I am running a hub, I can import clusters, as you can see with the ROSA and the ARO cluster. I can also create new clusters that are customer managed. And this is sort of a difference between blending. How do you enable a customer to create clusters of OpenShift on different cloud providers, along with VMware, along with bare metal? So a lot of the same options, right? Under the covers, we're using a consistent framework. In fact, this uses the same Hive framework that you saw just a moment ago. But if I wanted to create a cluster, I can click through and I can modify the similar features that you saw before. I can change the size of workers, the region they're running in, and I can, again, deploy the same OpenShift platform. So the way that my application works with OpenShift is going to be one-for-one the same on each of these different infrastructure providers, public cloud or within my own data center. So I can create clusters, and then if I have a cluster that I created through an SRE service, I can import that cluster. By importing the cluster, I'm simply deploying a few pods, giving it a credential to connect to my hub, and then now there's an agent which allows me to deliver configuration policy, and even in some cases trigger the upgrade of that cluster as well. So you can see that for clusters I provisioned earlier, I can actually go and upgrade them to new versions of OpenShift as they become available. And that upgrade process will limit downtime in the cluster. It's going to upgrade the masters one by one so that the control plane can remain available. It's going to upgrade the worker nodes. It's going to drive a lot of automation so that an upgrade process doesn't have to be a multi-month planning cycle. And of course, because I can do this in a dev QA prod situation, I can run the upgrade in lower environments first, make sure I'm comfortable, and then roll it out to higher level environments from there. So from here, the thing that I want you to take away is that we have OpenShift as a platform blended with customer managed or SRE managed consumption models running on multiple cloud providers, Azure, Google, Amazon, and I can create VMware, I can create bare metal, and then I can import OpenShift from virtually any provider as well. So now I have a consistent way of viewing my inventory from Rackham, and I can do some really powerful things from here. For instance, I can search across all of these clusters to understand what's running and where. So I'm going to show an application called Pac-Man in just a moment. It's an open source implementation of everyone's favorite retro game, or at least my favorite game. And if you don't know why it's my favorite game, Advanced Cluster Management for Kubernetes, Pac-Man has ACM right in the name. So that's good enough for me. But when I run this query of namespace Pac-Man app, what you'll see is that across all of my clusters, I'm seeing all the objects in that Pac-Man app namespace. Doesn't matter where the OpenShift cluster is running, doesn't matter about its infrastructure, I'm getting the same view. So I can see all of the nodes across all of the different clusters that are supporting my app. Here you can see it's running across a couple of different clusters that are remote, and then it's picking up one worker node that's related, that's got part of the application on it on the hub. And I can see things like the related routes, for example. So the route is the network address that sits in front of this container application. And here are the routes below. So I can see routes that are local to that cluster, and this F5 route, which I'm going to talk about in just a few minutes. So search gives me a way as a site reliability engineer, as a developer, anyone who is trying to understand this complexity of what happens when I go from one cluster to many clusters. And I can create and save queries. So I could actually make this a saved query, my Pac-Man app. And if I am a site reliability engineer who's supporting specific things, I might have just a battery of pre-existing queries that I continually go to understand what's going on in my system. So I've got clusters, I can index them, I can search them very easily. Now, what else can I do to them? So once I kind of understand what's going on in the system, typically the next question is, how do I make the configuration of these things the same? How do I have, we've already seen the question about identity management. How do I deliver the same identity provider to every cluster? How do I understand the security exposures or vulnerabilities in these clusters? I've got certain technical standards that help support whether I am PCI DSS compliant, whether I'm VIPS compliant, et cetera. How do I enforce those technical controls and understand what's going on there? And so we actually also, I'm going to flip over to the tab here, expose a concept of policy in Rackham. The policies, just like clusters, are Kubernetes native. So maybe just to draw the point home, here I'm using just a more interactive shell, and I can see those managed clusters that I saw in the UI directly from an API call, right? Everything I can go through and get CLI. Great. So policies themselves are just other Kubernetes objects. I can manage them in a Git repo. I can apply them to my hub. And then what becomes really powerful is I can manage how to deliver that policy against my fleet. In this case, I can see there's a number of decisions that match all of my clusters. In this case, I'm managing all OpenShift clusters, and I'm actually delivering a console link, which is a type of configuration that drops additional entries in this tab up at the top on my OpenShift console and in my ACM console. And I can see that each of these clusters is compliant, meaning that the Kubernetes object described by the policy has been applied to the cluster, and we're validating that it hasn't been removed. So this is an ongoing validation. It's not simply a one-time set it and forget it. It's continuously going in and reinforcing it. Now, I can also drive policies for things like identity management or image manifest vulnerabilities. So let me take an example there. Here I've got the ROSA cluster that we just saw. And you can see I've got a particular operator kind called container security operator. This is delivered from the operator hub. I've actually deployed that because of a policy in the hub that said, I want to automatically deploy a certain kind of operator against my clusters. And this policy does a couple of things. It'll deliver that operator, and then it'll check for image manifest vulnerabilities. And so in this case, I can see that the two clusters that are affected are considered non-compliant by my policy because the operator is deployed, but we've discovered that some image, some container running in that host has an image manifest vulnerability. And so from here, I could use this. We can actually trigger alerts and then use that as a trigger to go and resolve the underlying issue. I can also define policies for things like authentication providers. And so here I've got a policy which is delivering an OAuth configuration for any cluster that matches this label. And we'll show an example of how do I configure this. So right now the ROSA cluster is the only one that matches that desired state. I'm going to go back to my list of clusters. We'll pick one at random. We'll edit it. And we'll add the same label. Just like a lot of things in Kubernetes that are very label-centric, here the placement rules are selecting clusters based on the labels that they have. So in this case, the placement rule requires this label to exist. I'll add it, click done, click back over to my governance. And in just a moment, I'll see a new matching cluster here, assuming I didn't have a typo. I'll see that that cluster is non-compliant, meaning that my identity provider that is desired is not there yet. And over the next 30 seconds, 45 seconds, it'll deliver the new object, make sure it's configured, and return a compliant status. We can come back and take a look at that here in just a few minutes. And there it's already flipped. So now I've just delivered the same identity provider across two clusters, one running as an SRE managed cluster on Amazon, another running as a customer managed OpenShift on Amazon as well. So where do I get policies? How do I create them? This is part of our Open Cluster Management Community project. So this is where we develop the APIs that you're seeing, the Kube-native APIs that are part of the product. And in particular, we've been working with other vendors and stakeholders in the community to define a standard library of clusters. Of policies. And so these policies are categorized based on the NIST 853 standard, and they deal with technical controls that help support a certain set of audit controls. So an audit control might require me to do something like limit how many cluster admins are available on the cluster, or define specific roles that must exist on the cluster, or specific role bindings, or that must not exist. I might want to enforce limit ranges. I might want to enforce etcd encryption across all of my clusters. And so the standard library that you see on my GitHub page that's up has been applied. And so that is a lot. Anyone that you see in the policies namespace, all of these were applied from that standard library. And for the clusters that match, I can see that there are some that these are all informed. So they're just simply auditing. Does the cluster meet the policy or not? And I can see where it's flagging clusters that are non-compliant. And then I can actually go and view those clusters as well. So I can see the compliance places, what's non-compliant, what needs to happen to go fix it. So policies give us a way now to express a consistent desired configuration that's being audited and actively enforced across the entire fleet, regardless of where the technical cluster is actually running. So I've shown you a couple of things so far. We've shown that we can create clusters, we can import them, we can index and search them to understand what's going on, and we can deliver consistent configuration and policy across those clusters as well. What about applications? So many current applications or current practices really revolve around GitOps. And in this case, ACM natively understands when I have an application that is managed in a Git repo, whether that's GitHub or GitLab or Bitbucket, how do I assign it to a set of clusters and ensure that it's delivered and understand its health? So in this case, I'm going to play with this app. This is the implementation of Pacman. that is going to get delivered across a few clusters in my fleet. So if I pull up this app, here I'm looking at a diagram that says I've got an application called Pacman app. And again, these are Kubernetes resources. I'll flip in just a minute if you'd like to see it, just a query, OC get applications, OC get subscriptions, OC get Ansible job. It's a little bit of a preview of what I'm about to highlight there. But the Pacman application needs to run across multiple clusters. And here, again, it's using that concept of placement rule. So any cluster that matches this selector, app/pacman equals deployed, the application will automatically get delivered to. If I remove the label, then we'll take the application off the cluster. If I add the label, which we're about to do, it'll deliver the application to the cluster. And it's deploying a few deployments, one for Mongo, and I can see the clusters that my Mongo deployment is currently running on. And I have a second deployment, which is the front end, which is actually the web app that we'll see in just a minute running Pacman. And I have a couple of routes. One route exposes the Pacman application, and you'll see the URLs basically encode the cluster name just to give you an idea of where it's running. I do that intentionally to help make this a little bit more consumable. But if I open up the application at the top, you can see that this version of Pacman is coded to tell me the cloud and the zone that it's running in. And that'll become relevant here in just a minute. Okay, so it's running on two different clusters. Both of these US East, that's AWS, US East, and US West in AWS. Let's go deliver it to a cluster running on Google. And this one is running in the Europe West 3 region. So I'll simply edit the labels again. We'll add my application label. We'll go back to my topology view. And within a few moments, I'll see a new cluster. I'll see that Europe West 3 cluster appear. And I'll see the application begin to get deployed. So we'll see some of the green checks go into little yellow warning icons as it actually begins to deploy new content. So here I can see the subscription is currently not synchronized everywhere, right? I can see it's in progress. I can see the clusters that it matches. I can now see that Europe West 3 cluster. So think about just for a minute, this is an application that with a simple label change is getting spread out across 2 clusters in 3 regions on 2 continents. And all it was modifying a label from the control plane. And the reason that this is, I think, more interesting is that now I see, okay, I've got the 3 specific routes, but notice these objects that I kind of highlighted a minute ago, the Ansible integration. As much, I think Stu really kind of made this point, right? That when you think about cloud native, there's lots of different parts of that. And it's not simply one specific tool that makes it cloud native or not. In this case, the Pacman app runs happily as a kube application all day long, but I now start to bring together multiple clusters. How do I have consistent global routing in front of it, global load balancing in front of it? If I am a traditional enterprise, I probably have a ticketing system that I want to record each of my changes along the way. So every time that I automatically, through this DevOps SRE optimized process, deliver a new change to a cluster, I want a record in my ServiceNOW environment to tell me a change happened. And so as part of the application that delivers pods and routes and services, there's also, I can see 2 Andable jobs, one of which is a pre-hook job, one of which is a post-hook, and happens to be running Ansible Tower on the same cluster in a containerized form. And in my Ansible Tower, I've got a job which knows how to create a ServiceNOW ticket and a job that knows how to update an F5 Cloud DNS load balancer, which is sitting in front of these clusters across multiple clouds in multiple regions. And I can see the ServiceNOW record has already been created. So we'll take a quick look here. Let me refresh my ServiceNOW. Dun, 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 dun. And once this is logged in, I'll actually be able to see a new change ticket that references, in this case, all 3 clusters, right? Because I've scaled it out to the Europe West 3 region. And so here I can see at the top, the most recently created ticket, update for Oscar Lima, Oscar November, and Oscar Kilo, all 3 of my clusters, and I can click into the ticket to see what's going on with that if I want to drill into more information. And the contents of that ticket were defined by what was in the Ansible job. And at the same time, I can see that the job for F5 is still running, but we'll probably be able to catch it here. Here I can see that my F5 DNS group originally had 2 entry points, one for Lima, one for November. And as I refresh this, I will see a 3rd one now for Kilo. Okay, great. So now the application got scaled out to a completely different cloud, still running OpenShift with the exact same API, the exact same expectations, the consistent open hybrid cloud footprint that OpenShift provided for Pacman. And Ansible helped me then integrate that entire system together. And so now if I go back to my application, this other route that includes F5, you can see is just one location. It's deployed in all 3 clusters, but it's one location. And so if I open this one, now the reason why I include the cloud and zone at the top becomes relevant. You can actually hit this URL right now and play Pacman if you would like. And your cloud and zone will reflect whatever particular cluster you got routed to when you hit that global load balancer endpoint at the top. Okay, so let's see if I have time to change the background. I just got a quick feature request. Somebody wanted a green background instead of a blue background. The key thing that I wanted to highlight, and my PR isn't staged correctly, unfortunately, is that I can modify the color, right? So I can change something about the deployment. See if I've got this committed. I didn't commit it yet. It's okay, we're gonna get it done here. We'll update my branch. And now, one of the changes that is staged in the branch is this change to modify the image that's going to get deployed. And we'll go ahead and I'm just going to approve it and merge it. And the key thing, I don't know if we'll get to it before our time runs out, but this will actually drive an update into the application that'll get detected on the GitHub branch. Rackham will notice the change and then we'll then begin delivering the new version of that deployment out to all of my actual clusters. So in just a few minutes, the actual Pacman app that I had deployed with a blue background will get converted over to one that's running a green background. And the only thing there is to highlight, again, a very simple way to change everything in the fleet with one control surface. And then finally, the last thing that I wanted to highlight before I drop here is integration with Grafana. So I've actually done a little sleight of hand here to switch to a hub that's running the same system, but has different clusters that are attached. And here I'm showing each of the clusters that are under management are sending their health metrics using Thanos back into the hub. And then I'm able to view what cluster on AWS, on Azure, on GCP, et cetera, are doing. I'm able to see their health, their CPU, their consumption. So here I've got a single integrated view of health information that is automatically configured as soon as I deliver my management agent, which we call the clusterlet from Rackham. Things that I want you to take away. What I showed you was a simple way to consume OpenShift from different consumption models across virtually all the major cloud platforms, along with VMware and bare metal. I showed you how we could make it easier for users that have to make sense of this new information, how to consume it using our search capability, being able to drill into specific areas that are interesting. I showed you how we can drive consistent configuration across those clusters. Examples where we deliver new operators, like the container security operator that begins to scan for image manifest vulnerabilities, how to configure things like authentication, and I can plug in anything there, network, storage, et cetera. I showed you the open library that we're developing with others in the community to standardize how these technical controls that help an enterprise support its security and compliance posture or its configuration and consumption posture to make that just part of your DevOps process from end to end, more DevSecOps, if you will. I showed you an application that, in addition to being fun to play, is delivered across multiple cloud platforms, running OpenShift across multiple regions and 2 continents. And we rolled out a new deployment very quickly. And we'll see if my change has made it out here yet or not. Let's see if the background is now green. It's not green yet. Okay. At some point in the next few minutes, it will turn green. But what was key here is that the application could get scaled out across 3 clusters. I used Ansible to bind some additional parts that sit around the OpenShift cluster. Integration with my change management process with ServiceNOW, integration with other SaaS services, or even it could be an Andable job that updated a big IP appliance in my data center. But I'm updating global load balancers in front of these clusters that it's deployed on. And then the ability to understand observability data, metrics, and health information across the fleet.
I do have a quick question.
Sure.
So the integration with ServiceNow kind of got me thinking on the governance checks where you're looking for compliance with some of your configuration policies.
Mm-hmm.
If you find that you fail a check, can you integrate with ServiceNow to open an incident to track that?
Yes. So as part of the governance framework today, and some of this, you would have to hook together some building blocks. But today, when a policy finds a violation, it will fire an alert. It will fire an event, which you can turn into an alert. And one of the things that we're working on with that Ansible integration that I showed you for apps is the ability to trigger Ansible jobs for any part of the system. An Ansible job that fires as part of an alert from security, an Ansible job that fires as part of a cluster lifecycle event. So before I create my VMware cluster, I need to go to some archaic system and update a DNS route, or go to IP info blocks and reserve IPs, or whatever that thing is that sort of sits outside of the typical install process. But we'll have lifecycle hooks with Ansible jobs for cluster lifecycle, for security, just like I showed you for apps. So the alerts today, the integration with Ansible job out of the box is coming.